Oh, come on, you cannot be serious right now.
My biggest hurdle on every fabrication project, it doesn't matter what it is, the one thing that never fails to fail is me.
Hey Garage Fabbers. On a previous episode, we built and installed this fancy engine cross member on Caroline's Mighty Max on top of this even fancier stand. The purpose of that stand was to hold the bushings for the lower control arms in their factory position while I built some mounts for them. Everything worked out fantastic except for one small problem that I just now discovered. A couple weeks ago, I ordered some bushings for my custom lower control arms, and then somewhere along the lines, I decided to make the lower control arms adjustable so that I can easily change caster and camber on the alignment rack when the truck is done. But in order to do that, I needed some wider bushings. So I ordered some more bushings, and immediately after getting them, I misplaced them. And when it came time to welding the bushings onto the jig in the perfect position, I grabbed the wrong bushings. That said, currently the bushings welded to my jig are the incorrect width. Again, the purpose of these mock-up bushings are to help me design and weld on some tabs that go on either side of this bushing, but because this bushing is not the right width, the tabs would not be the right width, and that causes a huge problem. Luckily, a local Garage Fab viewer has unknowingly saved the day. Twice, actually. The adjustable bushings I'm making today require a large washer on both sides of the bushing. Without them, they're not going to work properly. We'll talk a little bit more about that later. More importantly, I was planning on making these washers out of a 1/4 inch thick steel with a 2-inch hole saw. If you've ever done it, you would know that this takes a really long time. I kind of dropped the ball on that one. I didn't give myself enough time to create these washers and finish this video on time. I would have had to create some sort of stupid filler episode just to meet the deadline. But right about the time I realized I dropped the ball, Marcus reached out. If you ever need anything CNC plasma cut, let me know. As a matter of fact, Marcus, I need several 2-inch circles cut out of a 1/4 inch thick steel. He knocked those out for me and is the reason you're seeing this video right now. Thank you, brother. The reason I said he unknowingly saved the day twice is because I can use these in the fabrication process to make my mock-up bushing the correct width. Let's get to work. I'm going to start by tracing the shape of the cross member onto a piece of cardstock so that the cardstock will fit nicely up against the cross member and under the frame. Then I'll roughly mark around the bushing so that I have an approximate bushing location and mark the center of the bushing. I'm going to do this on the front and the back because this bushing is in kind of an angle. So the front tab and the rear tab are actually going to be different, 2 separate pieces. So I need 2 separate cardstock templates. After making the cardstock template, I'll transfer that over to some 1/4 inch MDF for a tracing template. After cutting out the wooden template, I'm going to measure in 3/16 of an inch from the edges that contact the cross member and the truck frame. The purpose of that is because my plasma cutter doesn't cut flush to the edge of the template, so by removing 3/16 of an inch from the template itself, when the plasma cutter passes by, it's actually going to add 3/16 of an inch to that side. I used the cardboard template to mark where the hole is going to go, drilled that out, and now we can assemble everything and see how close we got. Oh, I forgot the spacers. That would have sucked. These spacers are to make the bushing the correct width, and the shape of our back plate is the right shape, but it looks like it needs to be trimmed because I have a huge gap right there that needs to be handled. I got to be able to move this plate all the way in to get rid of that gap. So we'll make some trimming on there, and that should be good. Then the front plate, wow, the front plate is about perfect. All right, I'm gonna take this back apart because I need to get this gap to close. I can't get this plate to move forward enough because I need to trim a little bit off the back sides of here. I'm probably gonna trim off about a 1/4 inch and then we will retry it. I almost made another huge mistake, but I caught it, thank goodness. I'm currently using these washers as spacers to make my mock-up bushing the correct width. That's not what these are intended for. One of these is supposed to be on either sides of the bushing on the finished product. So the tabs actually need to be set, not the width of the bushing itself, but the width of the bushing with one of these on either side. So I actually need to add 2 more of these before test fitting those tabs. Let's try that. Okay, so we've got 2 washers to correct the size of the bushing. Then we'll add 2 more washers to account for the size of 2 washers. And now let's try our plate again. Wow, okay. I'm really glad I didn't cut that off. It looks like it still needs to be trimmed a little bit, but it's dang close. A 1/4 inch would have ruined this plate and I would have had to start over. I was gonna completely weld this on, but there's something I need to do to these holes. I think it would be a lot easier if it's not mounted to the frame. So I think what I'm gonna do is I'm going to lightly tack weld these in place so that I can mark up where these holes need to go. And then we'll snap them off and change those holes around a little bit. So with everything the way it is right now, we could technically weld it all up and be done with the front cross member. But as mentioned at the beginning, I want these lower control arms to be adjustable for alignment purposes. So I've got to install these fancy things, which I ordered for a Toyota 4Runner. Everything that I'm doing today, I've basically stole from Toyota, their entire design, the operation of it all. I just really like how it works. These were really expensive. I'll leave the part numbers in the description if you want them, but I'm sure there's probably cheaper options than going with the Toyota route. But alas, we're going the Toyota route today. So before I get to modifying the tabs that we just made so that they're adjustable, figured let's go to my work and look at an actual Toyota and see how these guys work. And then it'll probably make a lot more sense as I'm trying to mimic that on the Mighty Max. On the 2008 4Runner, the front lower control arms are held on by some fancy cam bolts. There's a cam in the front and another in the back. Each of these cams are trapped between these stopper thingies. When the cam rotates, the stopper causes the control arm to move in and out. Hidden behind those cams is an elongated hole in the bushing tab that allows the bolt to slide back and forth. So the first thing I'm going to do is turn these holes that are in the tabs right now into ovals. I want the control arms to adjust in and out. That pushes the bottom of the tire in and out, which changes camber, and up and down wouldn't do a whole lot of anything other than changing the geometry of the suspension slightly, and we don't want to do that. So I'm going to draw a line across my bolt hole, and I'm going to use a level to do it. If you notice that when I draw this line, my bubble level is not level. That's because my floor is not level. So now we got our line going across. That's our level line. So because my floor in the garage is not level, my entire truck frame is not level. So this is what I'm fighting with all the time in this garage. So I don't use a level often, but when I do, I know that level for the truck frame is with the bubble kind of touching and slightly crossing that left line a little bit. So I'm going to finish marking those lines on the tabs, then I'm going to break the tack welds on the tabs, bring the tabs over to the bench, and we're going to oval out those holes. All right, I got my lines on my plates. I need my ovals to go this direction. So what I'm going to do is I'm going to drill 2 more holes on either side of the existing holes. This is a 9/16 inch hole. I know I need this oval to be about 1 7/8 inches wide. So it'll be 9/16 by 1 7/8 inches wide. If you're not in America and you're going to be using these Toyota guys, I think it's like 48 millimeter wide oval. And if you saw a video a couple episodes ago about me using these with my Rotocut hole cutters, that's what we're going to do, but I don't have a small one made. But I do have this little piece of metal laying around that has a 9/16 inch hole in it, so I'm going to use this as a guide. So this is my 1 7/8 or 48 millimeters wide mark. I'm gonna just eyeball this centered on the line and clamp it, cut the first hole, and then move it over, and then cut the second hole. So now we have 3 overlapped holes with these fancy little peaks in there that will actually keep our bolt from sliding. So in order to get the bolt to actually slide in this slot, we got to get rid of these peaks. This is going to be a bit of a greatest hits video because I'm going to bring back a tip I shared a while ago with my router with a carbide bit installed. That's how we're going to knock those down. I'm going to tack weld this to the bench because I don't think I have enough room to clamp it and use my router, so I'm just going to put a couple tacks once I get all these cut out, and then with the router just go down the line each one and knock off those peaks real fast. I just realized I was saying different measurements than what I was actually measuring a few minutes ago. I kept saying that I needed this oval to be 1 7/8 inches. It's actually 1 3/8 inches. The 1 7/8 inches is actually the size of the cam itself, which is what I had stuck in my head. Thankfully, I was making the holes the right size, even though I was saying the wrong measurements. I've already shared this tip on Garage Fab once before, but a whole lot of people have subscribed since then, so this one's worth repeating. I've got this carbide bit set that's meant for metal with a 1/4-inch shank that's meant to go in a tool like this. But I have a handheld router with the same 1/4-inch shank. I learned that I can put these carbide bits in the router to create a whole new tool that completely changed my life. We now have much wider holes that our bolt can slide in back and forth. The last thing we have to do is to create something that our cam can push up against that will actually push the bolt side to side. And what I decided to do is get some key stock. This is the stuff that keeps pulleys from rotating on a shaft. It's a hardened steel. I don't think it needs to be hardened, but it was already 1/4-inch. I think it's going to be really handy. I'm going to use that as the sides. So I'll cut a few pieces and weld these on perfectly parallel using a piece of 2-inch steel. I've decided to cut these pieces into 1.5-inch lengths. So I'm going to mark them all at 1.5 inches, cut out 2, 4, 6, 8 pieces, clean off one of these sides of this shiny finish that they have so that we can get a good weld on it and then weld them on. Two things I learned just now. One, my 2-inch spacer is too much. I wanted a little gap in there, so this didn't bind up when it was trying to turn. It would have a little bit of free play, but that's quite a bit more than I wanted. So I've got to make a spacer that's a little less than 2 inches wide for those.
The second thing I learned while welding is I think this stuff is galvanized. I know I should be wearing this stuff all the time when I'm welding, and I don't, but welding galvanized steel is a little bit too much even for me. So I'm going to continue using this stuff, but in the future, I will probably look for some plain mild steel 1/4-inch square bar for this. But for right now, I'm just going to try not to breathe it in. Well, the welds are lacking in beauty today because I found that my welding hood does not fit over my mask. So I have to take a deep breath and weld while I'm holding my breath.
So I don't really have the time to focus on beautiful beads today, unfortunately.
We're getting there.
I think these are done. They're looking really good, and I'm super excited because the sun is going down right now, and I'm not gonna have much light, obviously, and I gotta get this video uploaded tonight. So what I'm going to do is I'm going to slap these in place, put some heavy tack welds on there. I think what I'm going to do is I'm going to put the actual size bushings in there so that I can test them out. That means I have to break off the jig bushings, put the actual bushings in there, then fully weld them up. Might be a bad idea, but I think I'm going to do it anyways. And then that's going to be the end of this one. Well, that excitement was squashed immediately. Maybe you noticed while I was doing it, snickering the entire time. Check this out. All four of these look pretty much identical. Whoops. Two of these should be a mirror image because they're on the opposite side. So that's fun. So I have to cut two of these apart and put these stoppers on the other side. Oh man, that's what you get when you're rushing for YouTube. I love doing them. I love making the videos, but man, it is a headache. So here's what's gonna happen. I'm actually only going to weld on two of those today. I'm gonna figure out which ones I didn't screw up. I'm gonna weld those on, test those out, then we'll call it good. I made a big deal about these washers earlier and I almost forgot to explain what they're for. In our bushing video recently, we learned that this inner sleeve of a polyurethane bushing is supposed to be clamped tightly between the tabs. And with this big oval, that makes that a very difficult thing to do. The majority of the sleeve is exposed. So if I were to tighten this down, it would just barely clamp onto the upper and lower edges of that sleeve, and it could possibly pull through, likely turn, and that's what we don't want. So that's where these washers come in. Is that the hole in this washer is the same size as the hole in the sleeve. So when we put the washer in there, now that washer fills this entire oval, and when you clamp it down, we still get to clamp down on that sleeve like we need, and that washer is able to move around so that the sides of the bushing are fully supported no matter where the bushing is located in this oval. So once again, thank you to Marcus for getting those washers to me so that I can finish this video. Everybody say thank you, Marcus.
Thank you, Marcus!
Coming up on the Mighty Max, we've got to rebuild these tabs for the lower control arms, which is going to be
very similar to what we just did today, but rather than doing another video where it's just a bunch of the same stuff, I think I'm going to try to spin it as how to triangulate your lower control arms, because the Mighty Max only has one bushing on the front lower control arms and a trailing arm or a caster arm, whatever you want to call it, that if you're going to bag your Mighty Max, you probably want to get rid of that and triangulate your front lower control arms.
Then we're going to do some motor mounts so that we can mount the 4G63 in there. Where's, oh, I did it with the motor. Oh, there it is. So we can mount the 4G63 engine in here. So until then, guys, this is Man Candy signing off. Have a great week. Keep moving forward.